Hello, sir. Good evening. Am I audible?
Yeah, you are audible, sir. Good evening.
Good evening, sir.
Good evening, all the participants, and welcome back to the sixth session of our ongoing workshop. And today, our resource person during this session will be Dr. Amit K. Yadav. So, before starting the today's session, I would like to have a brief introduction about our speaker. Dr. Amit Kumar Yadav is working as assistant professor at School of Computer Science and AI, SR University, Telangana, India. His research interest involve artificial neural network, deep learning, machine learning, soft computing techniques, computer-based numerical and statistical big data and machine learning, artificial intelligence and pattern recognition, data warehousing and data mining, robotics, intellectual property right, pattern recognition, fundamental of IoT, data science and computer science based numerical and statistical technique, statistical data analysis, forecasting and analysis. He used the techniques like data-driven intelligent approach for solar radiation, wind speed, load forecasting, and prediction, resource assessment, and that of for the smart building and automation, big data analytic, preventive maintenance, and FDD of a smart building asset, energy management and operation building, automation and control occupancy detection, and for power system and power apparatus, condition monitoring and fault detection, power quality diagnosis, signal processing, and vibration analysis. He has also the experience regarding to implement the hardware, like we have solar power analyze, uh, sun tracker, sun simulation, 190 kWp grid interactive solar photovoltaic power plant, and atomic weather monitoring station, infrared thermal imaging, hybrid energy system, solar cooking system, and software expertise involve data analysis software like Veka, RapidMiner, Python, R, simulation and operation software like Homer, PV, Syst, MATLAB, Rat Screen, and implemented AI and machine learning algos like ANN, Fuzzy Logic, GAGP, ELM, GEP, PSO, ACO, SVM, PSVM, EMD, Wavelet. And he has vast experience in research, and also he is among top 2% researcher in energy as per Stanford University world ranking of the scientist, and to top 2% most influential scientist single year in 2023 by the same University Stanford. And his citations are about more than 2000. H index is 17, I-10 index is 21. So he has a vast experience in the teaching and research. So I hope that on the behalf of vast experience and working on this machine learning, deep learning, data analytic, and he has vast numerous research publications in international repute journals, national and international, and present various invited talk in national as well as international conferences. So now I would like to invite our today's resource person to present his valuable thought on this ongoing workshop, and I hope this session will be very interactive, knowledgeable to all the participants. So topic will be how optimization technique can be applied on for artificial intelligence. So these techniques are really very advanced and will be very helpful to all the participants. So now, dear Professor, welcome to this workshop, and over to you now.
Okay, sir. Thank you, sir, for giving me opportunity for this talk in this workshop. So, first of all, so this slide is visible to you.
It is being sharing. Not yet. We can see only black screen.
Here it is coming. Your screen sharing is paused. Should I stop sharing and again?
Yes, it's fine, sir. Now it is visible.
Okay.
Yeah.
So,
Please make full size of the screen.
okay. Now it is, sir, okay?
Yeah. This is not the full screen, sir.
This is full screen.
Uh, can you please move the slide?
Now slide is moving.
No, sir. No, no, no. Not
From
yet.
my side, it is moving.
Uh, no, sir. Your PPT is not moving.
Okay.
Yeah, it is now full screen.
Full screen is coming.
Yes, full screen is coming, and please move the slide.
It is not. It is not moving from my side also. Now, sir, it's visible?
No, sir.
Not visible. Anything not visible?
Only your name is appeared on the black screen. I think you should convert this PPT in PDF format.
Then it will visible?
Yeah,
Okay.
I think this will be easy to share.
Okay.
Yeah, usually
Okay, let me see here.
you can print as a PDF and then share it. How you are sharing the screen? I think you must share the screen, entire screen. Then it will be easy. You can use any format.
Okay, let me see.
Don't select the PPT. Share the entire screen. So this will be helpful if you are switching the other like Jupyter Notebook or other file.
Here, entire screen option is not coming.
Entire is on top left. On the top, you can see.
This one.
Yeah, in the blue on the top, entire screen is there. Top left, when you will click on the share at the bottom, you can see upward arrow sign. Click there. Then a new pop-up will open, and on the left top, you can see the entire screen.
Now it's coming.
Yeah, yes, it is coming, and I think this is PDF file now.
Yes, PDF
Yeah.
file.
Please make it full size by using Control L.
You're not working still.
Okay.
Okay.
Open the slide PPT. Please open PPT.
This
PowerPoint.
one.
PowerPoint only. Yeah, from this place it is working.
Now it's coming.
Yes.
Okay.
Yeah. Yes, it is coming. And along with the, will you use any like Jupyter Notebook or other file? Python?
That I will use after this one. Okay, because
Okay.
from my side, whole screen sharing is not coming. Okay, so that is the main problem. I opened this software platform also, right? So here if we stop sharing, and here if we, in most of the case it is here on top left. Now it's coming, sir.
Uh, the earlier was fine. This is not looking good.
Huh?
Sir, it's not looking fine. Previously it was fine.
Okay. If I go for window.
No, sir, endo will not be fine. You should select only the entire screen. This will be fine. And also, when you need to switch for the Python, then you can easily do. So otherwise, you have to unshare the screen and then again you will share the screen.
Yes. So that is the main option, because
Yeah.
from my side, this your entire screen option is not coming. Okay, if, here in Zoom it is coming, but here it is not coming at all. So that is the main issue.
Sir,
If you
when you
go,
will click on the green at the bottom to share upward arrow sign, new pop
here,
will open. Yeah. And
here,
yeah, now we can see the MATLAB. It's fine.
okay, you can see the MATLAB, right?
Yeah.
Okay,
And switch to the PPT.
let me see. It is coming.
No, sir.
PPT is not coming, eh?
No. I think you share the window of this MATLAB. No, sir, not from this place.
Not from this place, eh?
No.
Okay, so let me.
You have the desktop of this Zoom meeting, and at the
This
bottom
one?
you can see there are several icons. First is participant, then chat, then React, then we have the share.
Yes. I am sharing from that point here. Here,
Yeah.
na.
So when you will
After,
click that, when you will click on the share screen,
yes,
on the top right, a new pop will open. On the top right, there will be entire screen.
this one on the top right. This one you are saying.
Top left. Now open the click on the PPT. Yes, now it is working properly.
It's working, sir.
Yeah.
Okay,
Please make it full size.
this
Now
is working. This is
MATLAB is
coming.
also there. Now everything will be here.
Okay.
Yeah.
Okay.
You can make it full size of PPT.
Okay.
Fine. Everything is fine now.
Okay. Now, sir. Uh, okay. So, uh, my lectures contain first part, that is the basic of optimization techniques. First, we will try to see what are say basic part. Then we will see some different uh, components of say machine learning. After this, we will see how we can implement this optimization technique in machine learning, where we can use this optimization technique in machine learning. Uh, After this, we are going to see some basic problem, how we can solve with the help of say coding part. So now we will see where we can use this optimization techniques nowadays. It is used in say various fields like say mathematics, computer science, engineering, and economics. So we can say that it is very important for industry point of view, for uh, for maximizing profit to the industry and minimizing the cost. So actually what is happening in optimization, we have to find the best solution from a set of possible solution. It has a different components. First component is called as a objective function. This function needs to be minimized or maximized, and it represents a goal of optimization. Suppose if we take say MATLAB, say different tools are used to minimize the function say fx. Suppose we have to use that function for maximizing it, then we have to just write the function minus of fx. Then we can write it in the objective function. Then that objective function can be used for, say, maximization proper. So you can say that with the help of same tool, we can perform say maximization as well as say minimization. So this objective function contains say variables. This is called as say design variables. So with the help of these variables, we have to find out the optimal solution. Now, on these variables, we are having say different constraint. This is called as say restriction or limitation on the variables. So this constraint, it defines the feasible region where the solution lies. When we say feasible region, it means that all constraints should be satisfied. So here, the feasible region, so it means that means range of the design variable as well as constraint of the design variable should be satisfied. That is called as a feasible region. So there are say different types of optimization technique. First, we are having say linear programming. Here objective function and constraint both are in say linear. Then we are having this non-linear programming. As the name indicate here, objective function or constraint or say non-linear. Then we are having integer programming. So variable restricted to integers. Then we are having this dynamic programming. So here used for problem broken down into say simple problem. Then after this meta heuristic algorithm will come. Here we are having this say different types of meta heuristic algorithm. Say example which we are mostly commonly use say genetic algorithm, simulated annealing. Now here the question arises, what is the need of this meta heuristic algorithm, right? So now in real world, we will find out this objective function are not differentiable as well as a continuous. So therefore, we cannot use this type of say optimization techniques which is based on say differentiable and continuous natures of mathematics. Therefore, this meta heuristic algorithm come into pictures. So in literature, we will find out say more than 50 types of meta heuristic algorithms. So our main role, or you can say that being a researcher, we can implement these different types of this meta heuristic algorithms and see how our objective function get minimized or maximized. So we have to apply say different types of meta heuristic algorithm because one meta heuristic algorithm can't give better result in each and every case. Therefore, in literatures we are having say different meta heuristic algorithm. So we have to apply those algorithm and find out the result and see which algorithm is performing better on say particular type of problem. Now, at this point of time, we have seen about say objective function, what are say different types of say variables, and some overview of say you can say that different types of optimization techniques, right? Now here, as per the lecture schedule, as per the lecture topic, means optimization in say machine learning. Therefore, we will see some say basic aspect of say machine learning. So in machine learning, or you can say that neural networks, first of all, there is perceptron, which represents a biological neurons. When we say this artificial neural networks, it is totally resemble to our mind, to our brain. So you can say that here, if we take an example of this biological neurons, it has say dendrites, soma, synapses, and axon. Now we will see how we have to model all these parts with the help of say mathematical models. So then we can apply in the computational part. So here we are having say dendrites and axon. So electrical signals are modulated in various amount. This is also modeled in perceptron by multiplying each input value called the weights. Now here this weight come into pictures. This weight come into pictures. Now here actual neuron fires an output signal only when total strength of input signal exceed a certain threshold. So this is happening in our brain. This threshold is very important. So now we will see what is the importance of threshold in context with the neural network, because these play a very important role, as when your in net input is greater than the threshold, you will get the output. Otherwise, no output. So here try to see then here we are having this biological neural network, as we have seen here, this soma, synapses, axon, dendrites. So corresponding to these biological neurons, we are having this artificial neural network here. Soma is just remember to the node. These dendrites, this is just resemble to input. Then we are having synapses. This is resemble to weight or interconnection. Then here we are having axon. Here we are having this output. Now try to see here. This is an case of say simple say, perceptron models. So here what we are doing in say neural networks, we used to give the input x1, x2, x3 up to say xm. Then we are having this connecting bit w1, w2, w3, wm. Here this is summation sign. Okay, so again here after net summation sign, you will get a net input. Then it will pass through the activation function. After activation function, we will get the output. So we can say that all neural networks work on this basic simple concept. So now here, just just here, pay attention how mathematics play an important role here, because artificial neural network is nothing but it is just a mathematical computational analysis. So try to see here how we have to calculate the net input. Here x1 multiply into say w1. Here x2 corresponding to input x2, we are having w2 multiply into x2 into w2. W2 here is the say connecting bits. Then here x3 multiply into say w3. Then here xm wm. Okay. Here we are having summation sign. So all part get added. This is called as a net input xi into wi. After this, it will pass through this activation function. Why we are interested in passing this net input through the activation function? Because in our say high dimension data, we require, say, low dimension data. It means that we have to bring all this net input between, say, certain range, say from 0 to 1 and -1 to 1. Okay, so that's why when we are using certain activation function, we are bringing all net input in the range of, say, 0 to 1 to perform, say, computational analysis. After this, we will get the output. We will get the output. Now here, when we observe this net input equation, here we are having these connecting bits. Here we are having this connecting bits. Now, think for a time being, what is the value of this connecting bit we should keep so that we can get here, say, output close to the, say, target variables, right? So you can say that here in this example, this bit can be a variable. Okay, this bit can be a variable. So what is the role of optimization technique here? We have to optimize means we have to keep this connecting bit in such way so that error between the, say, predicted and target output should be minimum. So now here the role of the optimization technique come into pictures. Whether we can use any optimization techniques, say we can use, say, genetic algorithm or simulated annealing or particle swarm optimization. So here based on, say, dimension of inputs, here connecting bit matrix also get increases. Connecting bit matrix also get increases. Okay, so once we are able to optimize this connecting bit matrix, we achieve the predicted output close to the target variables. Now we will see what is the role of this optimization techniques in optimizing these bits. Now up to this point, we have seen about, say basic of this ANN, one perceptron model in computational of the output. Now here we have seen, say, activation function. Okay, activation function here. So in our literatures, we are having, say, different types of activation function. See here, when we are using here sigmoid activation function, so output will be, say, from, say, 0 to 1. When we are using this hyperbolic tangent function, say here output of this hyperbolic tangent function will be, say, -1 to 1. So when we will use here this hyperbolic tangent function, the output of this, you can say that these neurons will be from, say, -1 to 1. Then we are having this ReLU function, this rectifier linear input ReLU function. Here it varies from, say, 0 to 1. Then here we are having leaky ReLU function. Okay, so here it varies from, say negative point to positive point. Then we are having this exponential ReLU function. Now here we will see here a commonly used activation function here, and say step function, signum function, linear function, ReLU function, sigmoid function, and then here we are having hyperbolic tangent sigmoidal function. Now, what we have seen here, it has a x. Here x is nothing but it is just a net input. Net input. So with the help of net input, we will get the output when it pass through here. Net input is passed through different types of the activation function. So now at this point, we have seen that what is the role of activation function in say neural network, it is nothing but it just bring down the dimension of the data, say between say 0 to 1 or say minus 1 to 1, so that computational can be easy. So now here, where we can use say different types of activation function as per the problem. So when we are doing say regression function, there we can use a linear activation function. When we are doing say binary classification, there we can use a sigmoid activation function. So when we are using say multi-class classification, multi-level classification, there we can use this softmax or sigmoid activation function. Then we are having this convolutional neural network. Here we are using say ReLU activation function. Then here we are using say recurrent neural network. Here we can use say tan hyperbolic or sigmoid activation function. Now here, try to see here, these are certain inputs and it is passed to certain neurons. And here we are having the connecting bits. Here we are having connecting bits. And here we are having say net input. Try to see how we have to calculate the net input. Just multiply, create a matrix of say input. Here we are correcting and creating a matrix of say, or you can say that array of the inputs, array of this connecting bits. So what is the net input? As we have seen in say previous class, that it is nothing but a multiplication of the corresponding input with its corresponding bit. So here, just here corresponding to 0.3, we are having bit 0.2, and then here we are having 0.5, then here we are having 0.1. Multiply all these things. So here we are getting say net input, this one net input. After this, here the role of bias. When we when we are giving this bias to the network, what will be the output? Now you see here, with the help of bias, suppose here we are using this bias having weight say 0.45. Okay, here just add bias. Okay, here 1 into say 0.45 plus x1 into w1 plus x2 into w2. Here you will get net input say 0.93, right? So you can say that what is the importance of bias in say neural network. Okay, so you can see here, with the help of this bias we can achieve the threshold point. Okay, before this sometime we have seen that this threshold is important, because without threshold we are not able to get the result, right? So that's why this bias is important. Now you see here, by adding this bias we are just increasing the value of say net input. Therefore in neural networks this bias is important, so that we can go close to the threshold. Now at this point what we have seen here, this bias and weight and this activation function play a very important role in providing the output of the say neural network. Now here what we how we can apply the optimization technique here. Now you see here, this bias is the say we can vary it from say 0 to 1. Okay, so now with the help of say optimization techniques, we will see what is how much weight we will give to the neural network, so that it predict output close to the target variables, right? So in context of this bit here bit optimization, you are having one say back propagation training. Okay, back propagation training algorithm. So in most of the say machine learning problem, or when we are computing these neural networks with say different platforms like say MATLAB or say Python, so this back propagation can be implemented so on the backup of the program. Okay, so now here we will see how this back propagation is important. Okay, basically it's a mathematics part. Now here you see the beauty of this back propagation in say neural networks. So try to see here this in back propagation, what it will happen, it allow networks to learn from data iteratively by adjusting their weights. Now what we have seen here, this weights is important. So with the help of this back propagation algorithm, this weight get adjusted. So when this weight get adjusted, then the error between predicted and actual value get minimized. Okay, so this point is important. In every neural network, error between say predicted and actual output should be minimum, right? So you can say here that it is a say important part of say a training of complex neural architecture on a large scale data set. Here we can use all these type of optimization technique, say in natural language processing, reinforcement learning, and image classification, right? So this back propagation is based on say is based on say calculus and say linear algebra. So first one says chain rule of calculus. Try to see here what we are doing in chain rule of calculus. This we have done in say class 12th level, but here we will see the importance of this um, chain rule of say calculus here in say neural network, which state here how to compute the derivative of a composite function, right? Composite function just we have seen here from the networks. So here chain rule is used to compute the gradient of the loss function of each layers. Now what we have seen here, this weight and bias is important, right? This weight and bias is important. So it is a variable parameters. Therefore actually what we are doing in say chain rule of differentiation, we have to compute the gradient of the loss function. Now here what is meaning of this gradient descent? It is the optimization algorithm used to update the weight and bias of neural network during back propagation. Okay, so the basic idea is to adjust the weight and bias in the direction of negative gradient of the loss function to minimize the loss. When we say here loss, it is error. Okay, it is the error between say target and output variable. Target, what we are giving the say fixed value or target value to the network, and output is the value which is given by the network, and the difference between the target and output variable is called as error, right? So we can say that this error is a function of the weight and bias, right? So with the help of this back propagation algorithm, this weight and bias get adjusted in such a way so that error between target and output variable get minimized. Okay, so we can say that at this point this gradient descent algorithm is very important in say neural networks. Now here, actually what is happening in say back propagation algorithms. So here it process data in batches. Then here computational involved in forward pass and say backward pass, right? Then here we are having say matrix multiplication, here element wise operation and say matrix derivative, right? So we have seen here this activation function, say sigmoid, ReLU, tan hyperbolic. Okay, actually what this activation function is doing, it introduce not non-linearly into the networks, make the network to learn complex relationship in data. So this is the say beauty of this activation function. Suppose you are having say two set of say data. So take an example. Suppose you are having y, and this is called as say dependent variables, and we are having say independent variables say x1, x2, x3, or up to say x10. Okay, and say data samples of say one dependent and independent variables say 100 cross 100, right? So if we use the mathematics here, say when we go for say linear regression, non-linear regression, okay, we are able to find out the constant, right? But when we estimate the value based on say unknown value of say x1, x2, say up to x10, and when we will see the error parameter is more, okay, and it requires more computational analysis, okay. So when we are using these neural networks, it is nothing but it is a black box. We we put this independent variables and dependent variables, and it automatically learns a complex relationship in the data, right? So then we are using here derivative of this activation function. This derivative means here in say back propagation algorithm, we will see how we can use say derivative in order to find out the result, right? So loss function, here we are having say a difference between predicted output and the actual target value of the network. So at this point of time, we have seen that in say neural network, we are having these error terms, bait, bias, activation function. Okay. Now we will use this back propagation algorithm on these terms here. So here these are certain learning rates. Then we are having this regularization techniques. So now here we will see here. Try to see this one. X is the input vector as we have seen in the figure. W1 is the bait matrix connected input layer to the hidden layers. Now at this point, we are having mostly we are having say three layers in networks. First one input layer, second one hidden layer, then output layers. So on input layers we used to give the inputs. On hidden layers, I just similar to the brain, computational analysis take place at say hidden layers, and after hidden layers we are having output layers to get the output from the networks. So in between input layers and hidden layers we are having bait matrix as we have seen previous slide. So we are using this W1 as a bait matrix, okay, to denote all the bait connecting bait between say input value and say hidden between input neurons and say input neurons between input layers and say hidden layers, okay. So this B is the bias vector. Again W2 means bit matrix between hidden layers to output layer. B2 is the bias vector of output layer. Y as the output of the network. Y Y cap here we are denoting the target output. Sigma activation function, we are taking here sigmoid or say ReLU function. L is the mean square loss function. Okay. Now here we will see here, when we go for say forward pass, okay, as we have seen here at the net input. So here W1 multiply into say connecting bit this inputs, then here B1, right? Then it will pass through this activation function. Okay, say here sigmoid activation function. So therefore, this sigmoid activation function is a function of say Z1. Okay, now we are writing all these parameter in the form of mathematics. How we can use the optimization techniques. Then we are having say Z2. Then here W2 into H plus B2. Here this one related to your say hidden. This one is say related to your say hidden layers. Okay, hidden layers. Again on hidden layers you are having activation function. Take here say sigmoid activation function. We will pass all this Z2 to this sigmoid activation function. Okay. Now this loss function is a error function. It is nothing but say difference between say predicted and output. So this one, right? Now when we observe this loss function, now it is a function of say a connecting bit matrix, say input layer to hidden layers. Again from say bias value, again it is a function of say connecting bit matrix from hidden layers to output layer. So try to see this function, loss function. Now this y is a function of say w1, w2, b1 and b2, right? Now we have to compute the gradient of the loss function with respect to beta and bias using chain rule of differentiation and backpropagation, this one. So try to see here, this loss function is dependent on say W2. So apply this concept here, a partial derivative with respect to y, again y with respect to Z2, again here Z2 with respect to W2. Here again partial derivative uh, with respect to say B2. Again here partial derivative of L with respect to say y, then here y with respect to Z2, then here Z2 with respect to B2. Okay, and do this differentiation part, you will get all this value here. Then again here this is output layer. We are going from say back propagation algorithm. Therefore, first we are computing the output layer gradient, right? Then we are going for say hidden layer gradient here. Okay, say and this is a function of say loss function with respect to W1. Again here we go for and this function again for this one, again for this one. Just go for say chain rule of differentiation. Here we will get all these value here. Okay, after this here, this contain one part that is called as a learning rates. Okay, this learning rate alpha, it determines the step size taken in direction opposite to the gradient. Then here we have to use this hyperparameter that need to be carefully chosen. Too large learning rate may cause optimization process to oscillate or diverge, while a too small learning rate may slow down the convergence. Now here we have to achieve this optimum value. So therefore we have to define this alpha variable that is called as a learning rates. Okay. So overall beta and bias updated using gradient descent are essential for training neural network to learn from data by adjusting their parameter to minimize the loss function, right? So after this, what we have seen here, here we are having say an important features of say neural network architectures that has a big impact on both computational complexity and performance is the number of hidden layers. Now think for a time being, if we increases the number of hidden layers, then your this chain rule of differentiation will get increases and it will become more complex, right? So that's why in most of the say MATLAB software, or you can say that in say Python software, you are having say different library. Just call that library and do your work, right? But apart from this, at least we should know what is happening on say backup of the programming. Then we can develop the algorithm, or we can develop some new algorithm um, in upcoming years, right? So here, mm, uh, so on the networks we have seen the data, okay, like x1 to up to xm, right? Therefore this quantity of data always play a very important role in deciding the processing capability of the networks. Therefore before we start any say network, we have to go for say different types of say data analytics techniques, that is called as say data processing techniques, right? First we have to say see the data, again then we have to process the data so that we can remove say outliers from the data, right? Then here we are having neural networks, and it has a number of say hidden layers, right? So this number of hidden layers is used for say computational analysis. Typically, a network has more hidden layers. So once we increases the hidden layers, so it may learn more complicated patterns, okay, in the networks, right? So now here, how we can decide, say, uh, um, how much hidden layers are required, say particular say problem, okay? So it is based on say trial and tuning method, okay? First we can take say one hidden layer, then we say train the network, and then we can test the network and see how much error is there in the network. Again we take two layer, three layer. In this way we have to decide how much uh, hidden layer neurons are useful for a particular problem. Next here, now at this point we have seen that with the help of this backpropagation algorithm we can optimize the connecting weight and bias of the networks, right? So before this we have also seen that there are say different types of say optimization techniques. Now we will see say different types of say nature inspired optimization techniques, right? How we can use this nature inspired optimization techniques in say optimizing the say connecting weight and bias. So before going into say computational analysis part, we will see we will see with the help of say basic example how we can apply this genetic algorithm simulated aniline and particle swarm optimization with the help of say MATLAB techniques. So they will apply all these optimization techniques on say basic objective function. Now here, so this objective function will be as a loss function, will be a loss function when you are implementing these optimization technique in say neural networks. Okay, so only this is the difference. So we will see how we can implement this genetic algorithm simulated aniline on a say very basic problems. So if you are having this say laptop, so you just open this MATLAB, okay? So try to see here genetic algorithm. It is inspired by say process of natural selection. It uses say operators such as selection, crossover mutation. Then we are having say simulated aniline, okay? So simulated aniline, um, it is developed from say cooling process of the metals, right? So in metals, so there is a solid structure. So this solid structure achieved by say slow cooling. Okay, slow cooling means we have to decrease the temperature slowly, slowly, slowly.
Sir, excuse me.
Yes,
Are you using MATLAB now?
yes, yes. I will
Uh,
see the. I will.
Sir, we are not able to see your MATLAB. Can you please
No, no,
share?
no. I am not using. I will. I am putting some basic part here.
Okay,
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 regarding
okay,
this
okay.
code.
No,
Okay, okay.
okay, sir.
So I had put all part here. If anyone interested, just write down that basic part in their system. Okay, right. Okay, so that part I have written on the MATLAB also as well as PPT also. Okay, so not a big issue, right? So after here, after say basic analysis
But we
part, I
can
will
see only the PPT is stable. The slide which we are seeing here is global optimization method.
yes, 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 yes. I am on that slide. Okay, not a
Okay,
big.
okay, fine, sir.
Okay, right. So um, here, first we will see say genetic algorithm, simulated annealing, and say particle swarm optimization. So once you apply all these techniques, so and optimize the connecting bits of the networks, so then you can develop this hybrid neural network that is called as uh, say genetic algorithm neural network, a simulated annealing based neural network, particle swarm optimization based neural network. This is called as a hybrid neural network. So you can develop say different types of networks based on these techniques, and you can used in your research work. Preferably, you will get a good publication from all these things, right? So simulated and then we are having this particle swarm optimization. So it inspired from the social behavior of bird flocking or fish schooling. Okay, so here there is a swarm of particles. It is moving on say solution space. Okay, then we have to find out say global best or best position, right? So try to take. So here we are taking just say basic example, and we will see here how we can implement it with the help of say genetic algorithm. So now in optimization technique, first of all we have to develop the objective function, okay, based on the given problem. Okay, so here suppose a problem is given, so I am taking say minimizing the function. So it has say two independent variable, say x1 and x2, right? And this is your objective function, say x1 minus 2 square plus x2 minus 3 whole square plus sine 3x1 plus 4x1. And this is called x1, x2 is called as say independent variables. So here you are having this sine function, right? So on these x1 and x2, we are having the constraints. X1 square plus x2, say it is less than or equal to 10. X1 plus x2 is greater than or equal to 2. Now, what are say different range on say x1? So it's vary from say 0 to 5, and x2 again here vary from so 0 to 5. So now as per your problem, so this range also will get different. Okay, so it is not fixed as we have seen here. Okay, so it is different for say different problem, as well as this constraint also get different for different problem, as well as this objective function also get different for different problem. Okay, we will see say basic computational part of this genetic algorithm, how we can implement it. So now here, first part, how we have to write the objective function, right? So if you are having MATLAB, just open your MATLAB, just write here objective at the rate of x. This is the standard way of writing at the rate of x. If you are not using this at the rate of x, here try to see here this objective function. So it has say two independent variable x1 and x2. Here you have to write here at the rate of x, here x1 one variable, x2 another variable. Here, with the help of this sign, we are squaring this one here. Here we are having x1 minus x2 whole square. Then we are using here x1 minus 2 whole square. Here we are having this part again in the sign term, right? I think this part is clear. How we have to define the objective function in yum file of the MATLAB, right? Then we are having this non-linear constraint. How we can write the non-linear constraint in this way. This is the say standard part of writing the non-linear constraint. Okay, if you require any help how you have to write non-linear constraint, go in the MATLAB help section, write down non-linear constraint, syntax of non-linear constraint, you will get it, right? It's not a very big issue. So just here we define here, say here x1 square plus x2 minus 10 is less than or equal to 0. Here we are having, again we have to go for here, say minus of say x1, okay, minus of x1 minus of x2 plus 2. Here first of all we have to convert it into say less than or equal to 0 part. Okay, so when we multiply both sides with negative sign, so what will happen? Minus of x1 minus of x2 is less than or equal to minus of 2. So bring 2 on the left hand side, you will get here, okay, this part. In this way we have to write. Then what is the bound? Bound means what is the limit of say design variable, say x1 and x2. So lower bound on x1, so lower bound on x1 here we are having say 0 0. So both variable will start from this 0 0. If it is 1, then it will be 0 1. Okay, so if it is say this one 2, here 0, then it will go from say 2 0, right? So lower bound we have to write in this matrix. Then we are having upper bound. Here we are having this upper bound. This one 5 5, right? Now here, this is the say, basic example. Now when we are using this neural networks, so in objective function we have to define the loss function, nothing else. Loss function here, this x1 x2, it will become a connecting bit. Okay, connecting bit matrix, nothing else, right? So there in there we don't require this non-linear constraint, because this connecting bit say varies from say 0 to 1, or if you want to make it vary from say -1 to 1. Here this lower bound and upper bound, this digit will get changed, right? So now set option of the genetic algorithm toolbox. So this is say standard syntax when we used to run the GA tools. Okay, so this when we write here GA, you will we will get the syntax to run the optimization problem with the help of this one. Then here display, iteration, plot function at the help of say GA plot best, right? Then here set the option of the for the say genetic algorithm. Then here solve the global optimization problem using GA. This will give you say x, here FVL. FVL is the say value of the objective function, right? Here x is a design value of the objective function. So when you will run the GA tool, you will get say two value x FVL, right? So here GA, then here this objective function we will keep here. Then here it has a, why we are writing here 2, because it has a two independent variables, so x1 and x2. So that's why here we have written here 2. If it is more than 2, we just count and put it here. And here suppose we are not having equality constraint, so that's why we are using this box. If say any constraint is not happening, then we can use this box here. We are having lower bound, upper bound, so that's why we have to write here constraint, then here option, right? Then we have to go for the display optimum solution and minimum value. So F printf, so with the help of this one, we are going to display the optimum solution, like say x1, x2, then we are having minimum value of the objective function. Now, here, what are the main part we have to keep in mind? First one, objective function, define the non-linear function to be minimized. Then we are having non-linear constraint, define the non-linear constraint. So here, the deal function is used to separate equality and inequality constraint. Here, lower bound and upper bound, define the lower and upper bound for the decision variables. Then we are having options, set options for say genetic algorithm such as display setting and plot function. Then we are using this GA function, solve the global optimization problem using say genetic algorithm. The parameters here we are having objectives, function, number of decision variables. Here, try to see here, placeholder for linear inequality, because in our problem, we are not having say linear inequality and linear equality constraint not used in this problem. Suppose we are not using say linear inequality, then we put this bracket, and then this is called as a placeholder. Then here we are LB and UB means here lower and upper bound for the variables. Constraint, non-linear constraint function, option for the genetic algorithms. Okay. Now when we run this program, right, you will get result in this way. This is same, and this is here we are having this say MATLAB window. So optimum solution here we are having say x1 and x2. Here we are having say minimum value. Try to see here best value. Here we are having the minimum value. So best value we are keeping here. So x1, x2 value, you will get this value in the command window of the MATLAB. Next here, try to see here how we can use the simulated annealing technique. In say MATLAB. So basically, we have to minimize this function. It has a design variable x1 and x2. Say x1 minus 2 square plus x2 minus 3 square plus sine 3x1 plus 4x1. Right? So here we are having again in the same process, we have to define the objective function. Okay, as we have seen in the previous slide, at the rate of x, it has a design variable x1. So write down in this way. It has a design variable x2, write down in this way. Right? So here we have to initialize the guess. Means we have to initialize the starting process of this algorithm. Right? So here we are putting here say 0, 0. Right? Set option for simulated annealing algorithm. So here simulated annealing, right? Then display iteration plot function at the rate of SA plot based fit, right? So here, what will change here? This objective function will change when we are utilizing this in case of say artificial neural network. Basically, it is just a loss function there. Nothing will change. All syntax will remain the same. Then what we are doing here? Again, we have to write this will give you say optimum value of say design variable. Here it will give you say optimum value of say objective function. Then we have to write down this syntax simulated anneal BND. Here objective. Here this is the say initial guest. Here you are having this part. Now this is used for say displaying the result, optimum solution and the, say minimum value, right? So here when we run this program, so here you will get say x1, that will be equal to say 2.08, x2 here we are getting say 2 pointer. This is the optimum value of say design variable, and this is the say minimum value of the objective function, right? So these are say different iteration. Okay, so here now you see here, here it go up to say 1200 iteration, right? Means at this point you are getting say more stable value. More stable value, you can say that more best value, right? Next here, we are using this, how we can use this particle swarm optimization, right? So in the same way, just define the objective function, right? Then we can use a number of variable NVAR, means number of independent variables. Then again we have to define the lower and upper bound, so which is defined by this matrix, lower bound this one, upper bound this one. Then we have to run the particle swarm optimization. Then here option, option, here particle swarm, here swarm size, here maximum iteration 100. So you can change this iterative point and see in which case you are getting the best result. Then this is the standard syntax what we have to write here. X VL particle swarm. Again here write down this value of objective function. N here number of variable. Here lower bound. Here upper bound. Then here the options here. Display the result. You will get the result. This one. So here we are getting this optimum solution 1.91 or 2.91. So value of objective function here you will get this one. Next here, I think when you are having say multiple objective solution, okay, when you are having say multiple objective, means here before this we are having this single objective. So when you are having say multi objective function, then how we have to find out say optimum value, right? So there we can use this Pareto search. Okay, so I will not go into the details. I will go in the just syntax part, how we can use this Pareto search with the help of this MATLAB programming. So here we are having x is equal to Pareto search, here function, and we are number of variables, right? So here try to see, here find non-dominant point of multi-objective function, and where argument is the dimension of optimization problem, number of decision variable. Again this here Pareto search for number of variable. Fun here means function, objective function value, number of variables here A, B, right? So we can use this search point to the linear inequalities. Then here we are having subject to the linear constraint. Now here try to see here, when there is a linear constraint in the problem, then first of all we have to keep in this form, otherwise we will not get result. Okay, so most of the time most of the students are making mistake here. So the so we should keep our this problem in this matrix, right? So here in this way, if no linear inequality exists, then we have to set A with this bracket and B with this bracket. Then this is the standard syntax as Pareto search. Okay, define the set of lower and upper bound on the design variable in X, so that X is always in the range, say lower bound to upper bound. If no linear equality exists, set A equivalent A means this part, linear constraint. Okay, then here this is say output part of here of equality constraint. Then we have to put all these values. Then we have to write, first we have to write all these values, then we have to go for this syntax. Okay, just we are writing here first objective, second objective, then lower bound, upper bound, then we have to write down here objective function, right? Then we have to go for here Pareto search, In parallel to such, we are writing here lower bound and say upper bound. So when we will run the program, we will get the result. Okay. So we are trying to see how we can implement this with the help of the MATLAB. So this screen visible?
Yes, sir, visible.
Okay, so now we will see how we can implement this with the help of say MATLAB. So if anyone want to implement, so they can see this coding. Okay. Now here, we have to write the objective function. We are writing the same thing as in the slide. You can write it in your system. Same part is written here. Objective function, non-linear constraint. This we are defining in say MATLAB. Here, bound means lower bound and upper bound. On say decision variable say x1 and x2. Then we have to set for say genetic algorithm here. Here, okay. Then we have to solve the global optimization problem using GA and GA. So same syntax we have to write here. Then we are going here say print the optimal solution, minimum value of objective function, right? So we have to say run the. Now see when we run this program, now it is running. Try to see here, it is running. If anyone want to implement this program in your system, they are welcome to implement. Okay, so now it is running. Now it is running, it is taking time. Now you see here, uh, each and every uh, part, it is given here. Okay, so I am able to see in editor in command window. Try to see here, you will get here optimum value, optimum solution of say design variable x1, here design variable x2, here you are having say minimum value of the objective function. Next, here we will see how we can use this simulated annealing. Okay, so simulated annealing, first objective function initial guess, this we have discussed just now. We have to write down all the syntax, then we have to run the code. Yeah. Try to see it is running. Okay, so here you are having say this type of say you are getting time. Okay, you are getting time here. Okay, the processor times here. Okay, how much time they are taking, right? So when you go for here, what is this one? So go in command window, you will find out here say result. Okay, this part here, this is the optimum value of the design variable x1 and x2. This is the optimum value of the function. Okay, so if you want to see this iteration, it is shown in the say command window here. Then here after this part, we are going to see how we can see this particles form optimization. Try to see here particle form optimization. Try to see this is the particle form optimization. This is the say value design variable. Say x1 and x2 optimum value. This is the optimum value of the objective function. Next here, then how we can see this multi-objective function. Let me see whether it is running or not. Try to see here this. Now here, this is the x1 and x2 value of the multi-objective function. Okay, x1 and x2 value of the multi-objective function. Okay, so now I am opening the session for question answer. If you are having any question, uh, just ask to me.
Dear participant, you can unmute your mic for questioning. You are permitted to unmute your mic, or also you can put your query in the chat box. Or you can raise your hand for your query. There is one question in the chat box asking how we can define the number of iterations. Sir, I am audible. Amit ji, please unmute your mic.
Am I audible?
Yes, sir. Audible now.
Okay, now how do we define the number of iteration, right? So when we see the programming, so it is automatically taken. Okay, when we see say genetic algorithm simulated and lean, it is automatically taken say number of iteration. Okay, because based on say number, you can say that that inbuilt function will give you say optimum value, right? So it is run say, you can say that means directly, no need to define here number of iteration, right? But when we go for say developing say neural network architectures, and there we used to define say number of iteration, say 100 iteration or say 1000 iteration. Okay, so there is one goal point. Okay, goal point means we have to achieve say error say minimum error. Suppose in case of neural network say, if we are taking say mean square error, we will put it directly equal to 0, and we will take iteration say 100 iteration or 1000 iteration, right? So we will see the, as we are getting say less error, uh, then we can say that our network get trained. Okay, but here in this case, like optimization technique here, what in build function we are using, there is no need to define the number of iteration. Okay, so number of iteration automatically generated by the means inbuilt function. Any other question?
Dear participants, session is open for the discussion. Yeah, I think there is one more question.
Okay, so how do you consider uncertainty in a say uh, real world problem as far? And okay, now see, when we say uncertainty, it means that it has certain say changing variable. It has certain changing variable when we consider the case of the neural networks, right? Suppose we are having say 5 input variables, and corresponding to these 5 input variables we are having one target variable. Okay, so 4 input variables say x1, x2, x3 up to say x4, and one target variable say t1, right? So here what we will do, first we will go for say correlation plot. Okay, correlation plot, right? So when we see the correlation plot, so it will show you so interrelation between say independent variable and dependent variable, right? And in this case we just remove the say less correlated value, and based on say most correlated value we will develop the network, right? So in this way we are able to achieve say dynamicity of the network, right? Apart from this, if we apart from this, we are having one latest model that is called as say gated recurrent unit, or LSTM, or you can say that one latest model which is developed by say Google, that is called as a transformer model. So when we will use that model, so we are able to achieve say dynamic city in the say real world problem, right? Because once the input are changing, output is also changing, right? So with the help of say different models, we have to see which model is giving say less error, then we have to decide this model is best for this dynamic problem. Okay. Okay. What about some of us that don't use MATLAB? How can we go about say Python. Okay, so in Python you are having say a library, enrich library. Okay, just call those library. Okay, you will get the result. Okay, but here here in MATLAB, uh, so it is totally say dependent on say mathematical parts, so it is easy to understand here, right? But when we go through so Python, you can we can also use Python for the same programming part. So by calling say different types of library there, okay, you will find out different types of library there. Just go and call this library and put this optimization technique problem here. You will get the result. It's not a say big issue. So one problem can be solved by say different types of say software. I had
Any more question, please?
Thank you for I have only one question. After we get the result, what is the fine? Okay, now here okay, now in all the case when you will get the result, okay, definitely you will get the optimum value of the objective function, as well as say optimum value of say design variable, right? So that is the conclusion. Okay, so when we apply all these tools, okay, suppose if we take one single objective function and we apply say genetic algorithm, PSO, or say simulated annealing, you will see the difference. Okay, you will get say you will get say different optimum value in say different optimization technique. Why it is so? Because means different optimization techniques say is based on say different algorithm. Okay, so that's why we cannot say that this genetic algorithm is efficient. We can apply on any type of problem. So that's why we are having this genetic algorithm, simulated annealing and PSO. Apart from this, we are having say different types of nature inspired optimization technique, like say we are having ant colony, like we are having this river type optimization techniques. Okay, so lots of optimization techniques we are having in say literatures. So we have to use that optimization technique and see in which case we are getting the better result. Okay.
So I have a question.
Yes.
Sir, actually, we discussed here about all those optimization techniques and things. But just if someone wants to discover or create a new algorithm based on some natural algorithm approach or something, so what will be the correct way to start it? Means first we should start formulating the uh, expressions, or first means which is first, means from mathematics to natural or from natural approach towards mathematic expression?
Okay, so you are saying that suppose we have to develop the algorithm. Okay,
Yeah,
so
yeah.
in all optimization technique, very important part is say formulation of say objective function. Now we have
Hmm,
seen here, if we
hmm,
consider any types of optimization technique problem in real world, first part arises that how we have to formulate the objective function, right? Once we are able to formulate the objective function, then we have to go then we have to apply say you can say that means apply this conventional optimization
hmm.
technique,
Yeah,
right?
so just a little bit elaboration. I think it will give more clarity to my question. Like if we talk about gray wolf optimization, right? So the idea is they assume that the wolf pack will be arranged in a particular pattern at a such as locations, at a particular locations, right?
Okay.
So the point is, we are framing our problem according or means because we are afraid that some distance will be this one particular triangle only, or they should be in any pattern. That's what
No,
my
no,
point
no,
is. Why
no, no,
they,
no, no,
yeah.
no. Actually, uh, we are not say framing our problem as per the optimization technique, right?
Hmm.
Means framing is totally different from the optimization techniques, right?
Hmm.
Okay, so once we say frame our objective function, so that this objective function has a design variable x1, x2, x3, and it has a linearity constraint, non-linearity constraint, okay, lower range and upper range. Once we frame the objective function, okay, next part is the next question arises that which optimization technique will give the better result. That is the
Hmm.
question point. Okay, so
Hmm.
then we can apply a different type of optimization technique on our framed objective function, right? And then we will see that in which case we are having say better result. Now you see one optimization technique cannot give better result in every problem, right?
That's true.
So
That's
that
what the point was, because but when we design or devise any algorithm, it is more focused on a particular problem.
yes, 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 yes. The main conclusion here is that we have to develop objective function based on our problem. Then we have
Hmm.
to apply different this optimization technique to see the result. In which case we are having better result. You can say that we have to go for the comparative analysis, right? And then we can say that for this problem, for this constraint, we are getting this result.
So
So
one more
this is
question, sir.
yes,
Yes, sir. Thank you, sir, for answering this question. Actually, one more question is there, sir. So nowadays, because deep learning is giving very efficient result, always it was better.
yes.
So yeah, the point is nowadays one more pattern I have seen, like they are trying to merge deep learning with machine learning techniques.
Deep learning with
Together, they are like trying to combine both approaches they want to use on a particular problem.
okay, 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 okay. You are saying that means someone using say hybrid type of algorithm, right?
Yeah, so means that is simply like we give different streams of input. One is going to the neural network, other simply we are giving to suppose ensemble learner or something, and final result, the probability or whatever we are getting, we let's say using voting technique or something, we are getting the final conclusion. So that is the only approach, or there is some way where we can serialize the input, means like we do in ensemble layers are there, right? So
Okay,
means the result of the deep learning we are forwarding into the ensemble learner, something like that.
okay,
So can
okay.
we do like that? I mean, is it
Okay, now you see, Miss, when we will go for say hybrid model, okay, when we are doing say hybrid model, it means that we are taking advantage of both model,
Hmm.
right, to predict or to estimate say better result. That is the important theory behind any type of hybrid model. Now here the now here when we consider only one model, okay, say we are having artificial neural network with back propagation algorithm, right? Right. So in
Hmm.
that case, when we increases the number of data samples, right?
Hmm.
So in that case, means you will get a say more error, right? So basically, this error or efficiency or computational analysis is depend on say number of say data sample as well as the say computational algorithm, right?
Hmm.
So one model sometime not gets a better result when we increases a better when we taking any say large data set, right? So therefore we have to go for say hybrid model, right? So in hybrid model we are taking advantage of the say both model. So that part we have means you are doing in your problem when you are considering say deep learning model. Basically you are changing some parameters of the model and see its influence on the results. Okay, so that is the main part. If you want to apply, go and apply along with say you are we are having now say
No,
transformer model.
means if I'm working on something, let's say cancer detection. So I have a set of images with the CT scan, and
Yes,
also I have a suppose let's say seed database. So seed
yes,
database is basically data values,
yes,
right?
data.
So
Yes,
yeah, so I have created an ensemble model using let's say stacking or bagging something XBoost I have used. So it is taking one of the pipeline is
yes,
taking from the C database, but I want that there is another deep neural network which is processing the images of the cancer because usually machine learning is not good on images. So I'm
yes, yes,
saying
yes.
if we can process the images using the deep learning, and because the final result of the softmax layer, we are having some probability distribution, final result will get there, right? So that value we are forwarding as the input to the second pipeline of the stacking classifier, let's say,
Okay,
or something
okay,
like that. So basically, I'm saying if we want to merge the output of a deep neural network, which is processing some images of the cancer and some data values in the other pipeline, which is processing from the numerical values, and both of them I want to give as the input to a ensemble model for better efficiency. So something like this, actually, I just wanted to know, like, it will be a good idea or not?
no, no, means what you are saying that when we say that any idea is good or bad, okay, we have to means evaluate the model efficacy. Model, you can say that model error. Okay, go means what you are thinking, just do it and evaluate the model error, right? And when you are getting say less error, then you can say that means our model is working means better. Okay, so without what I want to suggest here, so without say evaluating say uh, model accuracy, we cannot say that what algorithm we have proposed that is working good or bad, right? So therefore here
Yes.
we means you have to go and evaluate the model accuracy and perform some comparative analysis. Okay, perform some comparative analysis with other model. Okay, then you can say that this model, when we are doing this modification here, we are getting say better accuracy. But in the case of cancer, what we have seen here, most of the PhD scholar are working here, so they are getting say more than say 98% accuracy level. Okay, so so it is related to the say classification problem. Okay, so if you go in some of the paper, they are getting say around say 98% is a very good digit, right? So that is the main issue where here we are getting. Okay.
So basically, I will just try and I have to check. Yeah.
Yes, go just check it with the help of say comparative analysis. Okay, here if you want to check it, go for say transformer model. This is say developed by say Google. So in this your Chat GPT is also using this
Which model you said, sir?
transformer model. Okay,
Transformer
transformer.
model. Oh,
Yes,
okay.
yes, it is mostly miss they are using this Chat GPT is using this transformer model in which
Okay. Okay.
information is processed say not sequentially parallelly. Means we can give all information to the model, and based on that information, model automatically learn the relationship between the means what information we are giving, right?
Okay,
Okay,
thank you, sir. Thank you.
the algorithm which are not efficient compared to.
Hello,
Yes,
hello.
yes.
Yes, I want to ask a question. Yeah, the AI algorithm is it a separate toolbox in MATLAB, or is it automatically inbuilt function in MATLAB?
Yes. Here in MATLAB, if you go for here, write down NF2. Okay, you will get a tool here. Okay. So basically in MATLAB, you will get one tool that is called as a NF tool. Okay. I think it will open in this way. Here, this way. Okay. So go for and give in the input. You will get the target value
Okay.
here. Right. Apart from this, you can write it's a basic code here. Say editor window in editor also. Apart from this, suppose you want to do some regression type of problem, say classification type of problem, there is a graphical user interface. Easily just you have to say give the data and you will get the result.
Okay. So it is not a separate toolbox.
Right.
That's what it is not a separate toolbox, an inbuilt function in MATLAB. It's not a separate toolbox.
I'm not getting.
Because I know that there is a separate toolbox in MATLAB called optimization toolbox. So I am asking, is the AI algorithm, inside the optimization toolbox, or it's an inbuilt function in MATLAB?
No. Regarding this, for implementation of this optimization technique in machine learning, okay, you have to develop the objective function. There is no box. Okay. For means here the problem will become hybrid. Okay, so regarding the hybrid problem, they are not providing any toolbox. We have to go with the coding part. Okay, because here here you have to develop a separate code for GA, then AI models. Okay, then it will be work, but there is no one single say toolbox. But apart from this, you will find out say single toolbox regarding this optimization as well as this AI model. Okay, but we are not having this hybrid toolbox, right?
Okay. Okay. Thank you.
Okay, the algorithm which we are somewhat not efficient computer. It is advisable to use in ML. Okay, so regarding this problem, not efficient, when we are saying that not efficient, before this we have seen that all algorithm are say problem dependent. Okay, we cannot use the same algorithm on say on all problem. Right. So regarding this machine learning, so we can use this genetic algorithm PSO simulated annealing for optimizing the connecting weight and bias of the networks. Okay, because error is a function of say weight and bias of the network. So once we are able to optimize the error function with respect to the connecting weight and bias, okay, then what we can see here, we can assign say optimum value of weight and bias to the network. So that is the main part what we can do with the help of this optimization technique in AI model. Though we are using this back propagation algorithm, but in some case based on the problem, okay, means we are not able to achieve say less error in the network. Okay, less error means we are getting more value of say weight and bias. Okay, so with the help of this optimization technique, means we have to adjust or we have to optimize the error function, means to get the optimum value of say weight and bias. Sir, we have do many optimize for which algorithm I need to consider on set. Should I depend to choose one more? Okay. Regarding the problem, you should go for say comparative analysis of different meta heuristic problem and see which meta heuristic algorithm is giving less error.
What?
Okay. Yes.
Open. Okay.
Here form. Thank you. Okay, but I am very interested in software programming. Where do one start with ML, ML machine learning programming? Okay, so here for this machine learning programming, you can implement this with the help of this any platforms, any platform, whether you are taking say Python as well as say MATLAB. So apart from this, our main suggestion is that this Python has a enrich library. Just call the library. We should know that which particular library is used for which purpose. Just that basic part uh, one can know, so they can easily do any machine learning type of problem. Okay, to develop a new server, we need to observe, study the nature of one particular element, take instant in what way is search is pre-develop an algorithm. It may take a lot of time. It's better we go for yes. When your algorithm is taking say means lots of time, it means that uh, it means that we have to go for the hybridization of the algorithm, right? Apart from this, one can also means just reduces the data profile in the programming, in the part. Okay, right? What here I can suggest that means your data dimension is large, or you are having say big dimension of data, just applies a different data processing technique. So okay, so once we apply say different data processing technique, we are able to reduce the dimension in the range of say 0 to 1, as we are doing in the say neural network. So once the dimension get reduced, then we can say that computational analysis part get speed get increases. Okay, sir, is there any more questions?
Israel asking, can we apply this optimization technique to time series analysis in machine learning?
Which one?
Last question,
To
sir.
develop an okay, can we apply these optimization technique to time series analysis in machine learning? Yes, when we say that time series analysis, in that case your means you have to give data with respect to time, nothing else. Means here in any machine learning models, means your this connecting weight will get changed, right? When we say connecting weight, it is a means your error is a function of the weight and bias, right? It means that we have to change this weight and bias, right? And so with the help of optimization technique, we have to assign this weight and bias in such a way so that we can get less error. Okay, because it is a changing parameter. So once you are having changing parameters, so we can apply its the optimization techniques there.
Any more question, please? Amit Panditji, do you have any question?
Sir, that was all from my side.
Okay. So dear participant, I think there is no more question, and questions from your side has been discussed. Also, I have the announcement that the feedback form has been shared in the chat box, and everyone is requested to submit that. And today we will not share the feedback form in the WhatsApp group. Okay, so here only the link you need to submit. So, dear Professor, thank you very much to deliver a wonderful session, and I hope that the content you deliver will be very informative and knowledgeable to all the participants. So, we are presenting here a certificate of appreciation proudly presented to today's speaker, Dr. Amit Kumar Yadav. He is from School of Computer Science and AI, SR University, Telangana, India. He presented a captivating and insightful keynote address titled Advanced Automation Method in AI at the 1 week workshop on next generation AI and machine learning held from 12 to 18 November 2024. We deeply acknowledge and are honored for his exemplary contribution as the keynote speaker. This program is jointly organized by Baba Farid College, Bathinda, Naxal University, South Africa, Purnima College of Engineering, Jaipur, Research and Development Cell, PCE, Jaipur, India, and Mathtech Thinking Foundation, Fazilka. Also, tomorrow is the last day of this ongoing workshop, and we request to all the participants, please join the session timely. Tomorrow, the speaker will be Dr. Opinder Kaur from Akal University, Bathinda. She will present some models based on artificial intelligence, machine learning, and deep learning, mostly related to prediction and analysis type. And some may be this model will be associated with the health science and environment problems, industrial problem, business problem. So several project will be presented, and that will demonstrate how the our previous lectures and many things, techniques, methods which we discussed and covered during the previous lectures. All this how we can implement, and this session will be really very wonderful to all the participants. So also, there will be validatory and certificate of participation will be awarded after uh, the workshop, and we will announce about the same. So once again, thank you to all the participants to be part of this ongoing workshop. And now it is time to close the session. And once again, I am requesting to all the participants, please submit your feedback form. The link is there. So thank you very
Okay,
much once
thank
again.
you, sir.
Thank you,
Okay,
sir. Thank you, sir, for your
Thank you, sir.
valuable
Thank
time
you, sir.
and valuable thought which you present for this ongoing workshop.
okay, thank you.
Your feedback form is showing Anand Nair.
Uh,
It is yesterday's.
just 1 minute, I'm checking again. 1 minute, please. 1 minute.
So
Okay,
can I
day
leave
is
now?
yeah, a day is fine, but the thing is that name of the speaker remain the same. So I am updating it. Yes, you can. The link is same. Link is correct, but the name was not updated. So you can do now. Now the session is over, but if you have the question, you can submit in the feedback form also. We will consider in the coming other activity, but now that today's session is over, please submit the feedback form. Thank you very much. Good night, everyone. The participants who are attending the session through live streaming, the link also has been shared on the YouTube chat. So you can access feedback form there. And now we are going to